Hello students, welcome. Today Form 3, Topic 2, Lesson 12, we are going to do stoichiometric of chemical equation. So we're saying this is a chemical equation in which the reactants and the products are in a whole number ratio. So what is mole ratio? Mole ratio is the proportion in which the reactants combine. Okay, examples. Example, we're having sodium carbonate solution reacting with hydrochloric acid, giving us sodium chloride, water, and also carbon dioxide. So the mole ratio between sodium carbonate and hydrochloric acid is 1:2 respectively. Okay, for you to know the mole ratio, you only check the balanced chemical equation. So here on the side of sodium carbonate, we have 1 hidden. So it is 1 here, ratio. In the side of hydrochloric acid, we're having 2 molar here. So the mole ratio will be 1:2 respectively. Okay, we go application of the mole ratio. The first one we're going to start is calculating number of ions in a compound. For example, we are going to start example 1. So we're having a question, calculate the number of sodium ions. So we are supposed to look for the number of sodium ions in 50 centimeter cube of 21.2 gram per decimeter cube sodium carbonate solution. So here we are given the volume and also the concentration of sodium carbonate in gram per decimeter cube. So the first step, we are supposed to look the molarity of this sodium carbonate solution, because we have already been given our concentration in gram per decimeter cube. So if we have the RFM, molarity can be gotten by concentration in gram per decimeter cube over the RFM. So the first step, we are supposed to look RFM of sodium carbonate. So sodium carbonate is written like that. So the RFM will be 23 times 2 for sodium, plus 12 for carbon, plus 16 times 3 for oxygen. This will be 106. So next we are going to write the formula for calculating molarity. So molarity is given by concentration in gram per decimeter cube over the RFM. So in our case, the concentration in gram per decimeter cube given is 21.2 divided by 106. So here we are going to get 0.2 mole. Okay, that's our molarity. So next we are going to look the number of moles of the sodium carbonate solution, and the formula for calculating moles will be molarity times volume used over 1000. So in our case, molarity is 0.2 times the volume used is 50 centimeter cube divided by 1000. So in our case, we are going to get 0.01 moles. Okay, thereafter, we have that 0.01 moles of the sodium carbonate solution. So we have to write now the reaction for the dissociation of sodium carbonate solution. So if we have sodium carbonate solution aqueous, it dissociates to produce 2 of sodium ions aqueous plus carbonate ion aqueous. So here, let's now know the mole ratio between sodium carbonate solution ratio the sodium ions. So here we are going to have 1 here ratio 2 on this other side. So the number of moles of sodium carbonate solution was 0.01 moles. So we ask ourselves, what about the one for sodium ion? We cross multiply. There we are going to get 0.01 times 2 divided by 1. So we are going to have 0.02 moles of sodium ions. So from there, we are supposed to look, we say 1 mole of sodium ion has Avogadro's constant, which is 6.023 times 10 power 23 number of ions. So here you will be given in bracket, but in our case it has not been given. So we are taking 6.023 times 10 power 23 as our Avogadro's constant. So we ask ourselves, what about 0.02 moles? This will be cross multiplied. We are going to have 0.02 times 6.023 times 10 power 23 divided by 1. So in our case, we are going to get 1.2046 times 10 power 22 ions of sodium or sodium ions. So that will be our answer. 1.2046 times 10 power 22 ions of sodium. That's our answer.